Okay, people, we are back at it again doing trigonometric equations and identities. This is sort of part 2 of the entire whole trig fiasco in grade 12 pre-calc. We're going to be looking at, trig identities and solving trig equations in this unit. So 7.1 and 7.2, the first two lessons, sort of focus on solving trig equations, both graphically and algebraically. So, what does it mean to find the intersection of, say, something like 1 equal to sine x? Well, if you solve it for sine x, then really what you're looking for is where is the sine curve equal to 1/2? So we can easily go ahead and sketch our sine curve. So our sine curve usually looks something like this. And here we are at 1 and -1. And if we go ahead and we draw the line 1/2, we are looking for where does this intersect. Now, excuse my crappy 1/2 line. So we can see there's two intersections right here. Now, if we think of the unit circle, we know that there are actually two places where the y value or the sine value is equal to 1/2. Okay, and that happens over here at pi over 6. The y value is 1/2, and it also happens at 5 pi over 6. So it stands to reason that those 2 points must be pi over 6, or sorry, 5 pi over 6 and pi over 6. So that's just like our unit circle. All right, what's next? What does it mean to solve a trig equation graphically? Well, we just did one, but we can do another one. So if you go ahead and you solve this for cos x, so this time we're going to divide both sides by 2. So we're going to get 1/2 equals cos x. I'm going to remind you that cos is like the x value on the unit circle. So we're going to be thinking about the unit circle in a moment. And for now, we can go ahead and draw our sine curve. So sine typically looks something like this. Now they want it from -2 pi to 4 pi. So one full cycle of sine is going to look like that. So that's from 0 to 2 pi. Then we can do that again. So we'll just call this 4 pi. And we'll call this 2 pi. And now to do it from 0 to -2 pi, it's just going to repeat and look like that. So we'll call that -2 pi, and we'll leave the rest of the labeling alone. Maybe I'll just toss in these ones here. Okay, so where is it equal to 1/2? So we're looking for, and this is 1, and this here is -1. Where again, we can draw a dotted line this time. So there's the line y equal 1/2. So as you can see, there's actually going to be an infinite number of solutions, right? It just depends on what the interval is. So there's a solution, there's a solution, there's a solution, there's a solution, there's another solution, so on and so forth. So if you think about the unit circle, where is the cos value or the x value equal to 1/2? Well, it's not pi over 6, because at pi over 6, it's square root 3 over 2. It's not pi over 4, because it's square root 2 over 2 there. It's actually over here at pi over 3, and that's positive 1/2. Over here is negative 1/2, so we actually have to go down over here. And I don't know if you guys remember, but this is going to be 5 pi over 3. Okay, so this value must be pi over 3. This value must be 5 pi over 3. Now, how could we get these other solutions? Well, we know that because of coterminal angles, we just keep spinning around this circle. Okay, so there's one full cycle of pi of cos. Here's another full cycle. So these 2 points here are just going to be coterminal with these ones. So if we take pi over 3, for example, and we add on 2 pi, okay, now I'll convert it to be the same denominator, so I'm going to make it 6 pi over 3. Then it stands to reason that, hey, this point here must be 7 pi over 3. What about this one? Because that's going to be that one over here. Well, again, add 2 pi to it. So that's going to be 6 pi over 3 that we're adding on. So we're going to get 11 pi over 3. As far as the negative values, well, you're just spinning in the opposite direction on the unit circle. So for negative, you're going going clockwise. So this would be negative pi over 3, and this would be negative 5 pi over 3. So there you have it. This one has 1, 2, 3, what have we got? 6 solutions for it. Okay, so that's algebraically. If we're going to do it, that's graphically. If we're going to do it algebraically, we can get the first two answers from the unit circle as you saw, but there's actually an infinite number of solutions because of coterminal angles. So we usually learn how to write the general solution, and it is something that they ask for on exams occasionally. You need to obviously use the period size. So just a reminder that for cos and tan, that's no issue. Or sorry, for cos and sine, having lots of issues today, right? The period size is 2 pi. If it's tan, then the period size is pi. Okay, so if I was to write a general solution for this question here, I would have to say, okay, I'm going to start on pi over 3. So you got to start somewhere, and then just add 2 pi times k, and k is an element of the integer. So what that does is if k is 1, then you're going to get this first answer, 7 pi over 3. If you make k 2, then you'd be adding 4 pi, or you'd be finding the next answer afterwards. Because k is an integer, it could be negative, so you could subtract 2 pi, which would actually give you this answer over here, the negative 5 pi over 3. Now, I don't know if you're noticing, but if I just have this one general solution, I'm going to be missing half my answers because I'm never going to get this 5 pi over 3 to work out, right? If I just keep adding 2 pi, see how I skipped over that 5 pi over 3? So there's another piece of this general solution where I start with 5 pi over 3, and then I add 2 pi times k, and I say k is an element of the integers. So these would be the general solutions for this scenario. And when I say they ask about it occasionally in the exam, I'd say that in some capacity the question comes up usually once per exam, in some capacity. Alright, let's talk very briefly about tangent. It's probably our least favorite one because it's so weird, but it says write the solution for tan x equal -1 from negative pi to pi. Now remember, this pi has a period, or tan has a period of pi, so this is like asking for 2 cycles of pi. Okay, so we can think about the graph for a moment here. Now just give me a moment here. I'm just gonna scroll over. Here we go. So what would the solution look like? Well, like I said, period is different. It's pi, and it has a restricted domain, right? You can't equal certain values for tangent, if you recall. So one of those values is over here at 90 degrees at pi over 2, right? Anywhere where the x value is 0 is going to give you an asymptote. So if we were to sketch out pi, so there's pi over 2, and this would be negative pi over 2. So one cycle of tan looks like this. Now we're wondering, where is it equal to -1? Like that. So where are the places on the unit circle where your tan value is -1? Well, here is 1. Okay, and this is either one of the pi over 4 ones, so this is 3 pi over 4. Whereas the only other place where tangent is -1, well, it would have to be down here in this quadrant. And that's going to be 7 pi over 4. Okay, so there you have it. It's just asking for the solution from -pi to pi. So this is 0 and this is pi. So one solution for this question would be 3 pi over 4. And then all of a sudden it's also asking us to go counterclockwise. So now this is 0, this is -pi. If we're going counterclockwise, this isn't 7 pi over 4, it's -pi over 4. So those would be my two solutions. Now down below I ask write the general solution to this same question. So the interesting thing to note for tangent is because the period is pi, you're going to go 3 pi over 4 plus pi k instead of 2 pi k. So there's the one solution, and to get the other solution you need to go like this. Or do we have it covered? Let's see. Is it possible? Well, let's write it down and we'll think about it. So one question I get a lot from students is, how do I know if I need, like when you have to have two general solutions for a question? Well, the answer is, is this formula going to generate all the answers? Okay, so if I make k -1, for example, am I going to get negative pi over 4? So if I make it -1, I'm going to get minus 4 pi over 4 once I get a common denominator. So 3 pi over 4 minus 4 pi over 4. Yeah, that gives me negative pi over 4. So I don't need both of these solutions. So this is the same way of writing the same answer. So you just pick one of them. So I would just say, well, let's stick with this one. There. All right. That typically only happens with tangent, by the way, where you write the two general solutions and only one of them is actually needed. So I thought I'd point that out. So recap so far. If we're going to do these, we need to think about which trig equation are we using. So is it sine, cos, or tan? That way we can figure out the period size and whether or not the question is asking for a restricted response, right? So is there a restricted domain? Is it asking for a general solution? Whatever. Last 2 points. If we introduce a b value, that's going to change some things because b value affects the period size, right? Because period is 2 pi over b. So all the questions we did had a b value of 1. What if the b value is not 1? Well, we'll see what happens. And the question might be in radians or degrees. That's not as hard to deal with, just something to watch out for. All right. So 2 types of questions that come up on the exam. Some of them are calculator questions, which are non-exact values, and then others are going to be exact value questions. So let's see here. Where am I? Yes. So these ones here that I'm giving you now, these are calculator questions. So the first thing you need to do is solve this equation for sine x. So we'll solve it for sine x, and we get that sine equals 2/3. Then you go find yourself your reference angle. So go inverse sine of 2/3. Plug that in on your calculator. Make sure you're in. Now this is where you check your domain. I need to be in degrees for this one. So when you plug it in, make sure you're not in radians, but you're in degrees. You should get an answer of 41.8 degrees. All right. And then you're asking yourself the question, where is sine positive? Because my ratio here is positive. So sine is positive in quadrant 1 and quadrant 2. So one of my answers is going to be my reference angle right here. So you can go ahead and put a box around this because this is one of the answers. The other answer is going to be over here. So we know the reference angle is 41.8 and we know this is 180 degrees. So you're going to go ahead and rotate around and your other answer is going to be 180 minus 41.8 and that's going to give you 138.2 degrees. Put a box around that one. All right. There's that one. Woohoo! Now this one, oh, it's ugly. It's asking for the general solution to this question. Now, lots of things going on. Number one, it's a general solution question. So when you have one of those, you're going to find your solutions the same way you did for the question above. Then you'll just tack on whatever the period is. Okay. Now you need to be extra careful with this one because the period is going to be different. So what I recommend you do right away with this question is say, okay, let's find the period. So it's 2 pi over b. Now my b value is 2, as I can see right here. So my period for this particular cos is actually pi. Okay. That's something to keep in mind when we're doing the general equations. Okay, we're going to deal with this in the question as well. So the first step you can do is you can solve this for cos. So you got cos 2x equals divide both sides by 5 and you get 1/5. Now, same procedure as before, right? Where you go inverse cos of negative or inverse cos of 1/5. Notice though how you always take the argument out, right? So in this case, the argument's 2x. In the question before it was x, so it's just x equals inverse sine. In this case, it's 2x equals inverse cos. So when you get your value here, so when you go to your calculator, now it's in degrees again, and you type in inverse cos of 1/5, I just want to double check my answer here, make sure I have the right one. So make sure you're in degrees or you're going to be very sorry because you'll have the wrong answer. Now I got 78.4. just to round to sort of an arbitrary decimal here. So I got 78.4 degrees. You need to divide everything by 2. So you can leave it like that, or better yet, divide by 2, and you can get like 39.2. There we go. Okay, now this is our reference angle. Okay, so where is cos? Go back to the beginning. Where is it positive? Well, it's positive in quadrant 1 and in quadrant 4. Now in quadrant 1, we already divided the angle by 2, so we know that one of the answers is indeed 39.2. But in quadrant 4, right here, we know our reference angle is 39.2. Normally, you know this is 360, and you're going to rotate all the way around and go like this. The problem is that one cycle of cos is happening in pi degrees, or 180 degrees. So if you're going to go 360, okay, so to find this angle, normally you would go 360 subtract your reference angle, which is 39.2, but you need to divide this by the period. Sorry, not the period, but by the b value. Okay, so divide it by the b value. There you go. So you have to remember to do that step in any question where the b value is not 1. I'm not dividing the reference angle by the b value because that already happened over here. So I'm actually going to be going 180 subtract 39.2, and you're going to be happy because you're going to get 140.8. I don't know why it makes you happy. It makes me happy though. There. So in a regular question, you'd be able to stop there because you have your 2 solutions. But this one's asking for the general solution. So you have to write, these aren't the actual answers yet. You get marks for them, but you're not quite done yet. So for the general solutions, my handwriting is horrible. I'll just print. Need to remember that you are adding whatever the period is, okay? So you can take your first solution, and for sine or cos, you're always going to have 2 solutions, and it's going to be plus pi k. K is an element of the integers. Take your other solution, 140.8 plus pi k. K is an element of the integers. So remember, this needs to be whatever the period is for the function you're writing the general solution for. So there you have it. That's about as tricky as they can get. Here's another one where we're solving it algebraically. It's got a b value again where it's not 1, and this one's in radians. We may or may not have to do this one. I suppose that we could spend some time doing it. So let's do it because it's in radians. So sure, let's roll. So part A is asking for solutions over this domain, 0 to 2 pi, which is going to be 2 periods, right? Because the b value is 2. So when I go and find my period of 2 pi and I divide by b, which is 2, I get that my period is pi. So on pi, from 0 to pi, I'd have 2 solutions, right? And then when I go all the way out to 2 pi, I get another 2 solutions. So in total, I'm expecting 4 solutions in this question. Let's see how it all goes down. So this thing's already solved for cos x. So I'm just going to say 2x equals inverse cos of 0. Now, this is an exact value, right? Where is cos equal to 0? Where is it equal to 0? Where's your x value 0? Your x value is 1 over here. Oh yeah, those are the ones that are pi over 2 and 3 pi over 2. That's where my x value is 0. So if you just do the one that's sort of in quadrant 1, you're going to get that. And then you solve for x, and when you divide both sides by 2, you get pi over 4. Okay? Now, but this is sort of a special one. I know the other answers here. Don't forget the period. Sorry, the b value is 2. So when you solve for your other one, you go 2x equals 3 pi over 2, divide by 2 on both sides, and you get 3 pi over 4. Now, I'm expecting 4 solutions. I only have 2. Remember, use your knowledge of coterminal angles to find the other ones, right? Now, if I was to draw a sketch of this, cos would look like that, except that would be pi, right? And then I'm going to do a whole nother loop of cos, and there's 2 pi, and it's equal to 0, which is down here. So as you can see along the x-axis, there's 1, 2, 3, 4 solutions. Now I found the first two. All I need to do is add my period, which is pi, to both of those solutions to find the last two. So if I take this one and I add pi to it, then I'm going to get that x is equal to 3 pi over or no, my bad. When I add pi, that's going to be 4 pi over 4 when I get a common denominator. So I'm going to get 5 pi over 4. That was close. Add pi to this one. Right? Again, that's adding 4 pi over 4 when you get a common denominator. So you get 7 pi over 4. There you have it. So there would be the 4 solutions I'm expecting. Now, they want a general solution in part B. So all I need to do is take, say, this first solution of pi over 4 and add the period, which in this case is pi. So I go pi k, and k is an element of the integers. You can double check and see if I add pi k, right, we already did, I get 5 pi over 4 for my next one. I'm never going to be getting these solutions that are like the 3 pi over 4 ones. So I know I need to take my other solution, that's sort of the other one I found first, and add pi k. There we go. There's the general solutions. All right, we are quickly reaching the end here. Yeah. We can increase the complexity of just everything that's sort of around the equation here. So this one you'll see is square root of 2. So just you might have to use your algebra skills to sort of isolate and solve. If it's not a value that's memorized, so if it's not one of your exact values, then you are going to have to use your calculator. On the exam, it's a giveaway, right? Like if you get one of these questions on the non-calculator part, obviously it's going to have to work out to an exact value. If you're on the calculator part and you're doing one of these, then you can probably expect a calculator question, although it's not always the case. So this equation, it's a little bit, you know, we got an equal sign, we got all this funky stuff. Just add 3 to both sides, right? So you're going to get square root 2 sine x equals, so add 3, you get 1, and then divide both sides by square root 2, so you get that. Now, this might not look like an exact value, but remember, if you rationalize this one, you're going to get this, right? So if I multiply the top and the bottom by square root of 2, so this is actually an exact value. So when I go and do inverse sine of 1 over square root 2, now square root 2 over 2 is the value of pi over 4, right? So the sine value. Now, what's the domain they're asking for? Ooh, this one's ugly because it's negative 360 to 0. Okay, so this is just my reference angle. Now, I like to draw the sketch and ask myself, okay, so here I am when I solved it all. Where is sine positive? Well, sine is positive in quadrant 1 and in quadrant 2, but we're actually going to be going in the clockwise direction because we are looking on the negative side of things, which is something that we haven't practiced for a while. So draw your picture. Now we know that this is pi over 4, and we are rotating this way. Now I cleverly wrote everything in degrees, so I'm just going to rewrite this. This is negative pi. So I rotate negative pi units, and then because I'm going in a clockwise direction, I'm going to subtract pi over 4, which is the reference angle. So one of my answers is negative pi subtract pi over 4. Get a common denominator, and you will get negative 5 pi over 4. There we go. Now generally they're asking for it in degrees, so I just realized that I should be keeping my answers in degrees, so I went ahead and did it in radians. That was just for fun, haha, just kidding. I had the right idea when I wrote this in degrees. So remember, this is 45 degrees. Okay, so we can just rewrite this one as negative 225 degrees, and there you have it. Now, for the last one, hopefully this doesn't get too messy. Here is your angle of 45 degrees, and we are rotating all the way around like this. Okay, so easiest way to do it is say, well, one full rotation's negative 360. Add the angle back, so you're back here and you land on the terminal arm. So the other answer is going to be negative 315 degrees. So negative 360 plus 45, there you have it. Now, they're also asking for the general solution. The b value here is 1, so the period is going to be the usual 2 pi. So what you can do is you can take your first answer, and you can say x equals negative 225 plus 360, right? 2 pi, k. K is an element of the integers. It looks like it says 36, okay. Ha! You're okay if you're 36. I'm less than 36, I'm okay. All right, and then again, plus 360, k. K is an element of the integers. There you have it, general solutions, all done. Whew, I hope we're getting to the end here. Oh my word. Right, the last kind of question you can get is the ones that involve factoring. Oh yay, I can't wait. So you saw these in grade 11 and we saw them at some point in the last unit now. The domain is ugly. Everything about this question is ugly. When you see one like this, if you like, you can say let x, actually I can't use x because they're using x right there, so I can say let a equal sine x. And then if you like, you can rewrite it. So this is the same thing as 6a squared minus a minus 1. And then you can do the regular decomp, right? So two numbers that multiply to a times c. So I need to multiply to negative 6, but needs to add to the b term over here, which is negative 1. So my two numbers are going to be 3 and 2. 3 times 2 will make it negative 3, so that it adds up to the appropriate negative 1. Now, I like to rewrite this step. Okay, so this is the decomposition. Okay, and then I like to jump straight to the factored form. Now, I have a's in it, and we can replace it later with the sine x. So when you look at the first two terms, you can pull out a 3a, and that's going to give you 2a minus 1, and then from the last two terms you can pull out just the plus 1, and then again you get 2a minus 1. At this point you can go ahead and resubstitute in for a, so a is sine x. Alright, that's dandy. And now you are solving two equations. So you're going to be setting it equal to 0 so that you can solve. And that's just the zero product property, all that good stuff. So you're solving one equation that looks like this. And you're solving the other side, which looks like this. Now over here, let's do this one first. So we can subtract 1 from both sides, and you're going to get negative 1 equals 3 sine x. Divide both sides by 3. Now this is obviously a non-exact value. We don't memorize that one. So you're going to go inverse sine of a third to get your reference angle. Now notice I plugged in positive a third even though it's negative because the reference angle is always in quadrant 1. Now if you're in radians, you should get that. And let's see, are there any places where that happens? Are there any places where sine is negative? So from 0 to pi over 2, because the domain is from negative pi over 2 to pi over 2. So I like to think about the positive side first. Well, and the fact is that sine is not negative in this quadrant. And then if you think of it from 0 to negative pi over 2, so that's going this way, sine is negative in this quadrant, so your answer would actually be your reference angle, because you are going counterclockwise, or sorry, clockwise, so it's a negative angle. So yeah, that's going to be your answer. Perfect. So there you have it. This one over here, move the 1 over to this side. Divide both sides by 2. Now, we know that there are places where sine x equals a half, so just go ahead and get your reference angle. So you can write that step. It's optional to write it, but it's always a good idea. And where's that going to happen? Well, in quadrant 1, it's at pi over 6. So let's see. From 0 to pi over 2, yeah, sine is indeed positive, so one of the answers is pi over 6. When you go from 0 to negative pi over 2, sine is not positive, so there's no answers there. So you have two solutions, pi over 6 and negative 0.34 radians. Thanks for joining me. Whew, that was a long one. But you can now do both of these exercises. Have fun, and we'll see you next time. Bye-bye.